Welcome to Train Signal. You're watching a lesson on wireless networks. So to get things started, well, let's, first talk about why we would use wireless networks, right? Why even use it? What are the benefits of using wireless networking? Well, the first one is real easy. No more cables! Yay! Right? A couple lessons back, we talked about the different cables, right? We talked about twisted pair and coaxial and fiber and all the different connectors and this and that. But there is one drawback to no matter what type of cable you use, and that is, that is still a physical cable, which means you have certain obstacles that are going to get in your way, regardless of the technical specifications of the cable. Okay, so wireless networking is typically easier to install, right? Because you're not actually running any cable anywhere. It's just stuff traveling through the airwaves. You have the ability to easily connect networks through walls and other obstacles without having to worry about drilling holes and patching things back up and stuff like that. It's a great way to quickly allow temporary access, right? Someone needs to come onto your network, they need to hook up real quick. Well, rather than trying to run a cable to wherever it is that they need to be connected, boom, have them wirelessly connect into your network. Then the last benefit I have listed is that it's equally secure. Although I have question marks behind that. So should I have said equally secure? Or is it equally secure? That is the big question that everybody always has when it comes to wireless. It's one of the main reasons that you still have people using wired networks. Because there's always that question out there that when there's stuff just traveling through the airwaves, is it as secure as when it's running along a cable? Some say yes, some argue no. Either way, that's a potential benefit. If you can set it up and you set it up right, the answer is yes. It can be as secure, so why not use it? Now, one of the main things that you need to take into consideration when you're setting up a wireless network is the placement of something called an access point, or sometimes referred to as a wireless access point, or a WAP, W-A-P. There might not be anything as important to the success of your wireless network as the placement of a wireless access point. And there's many questions that you need to take into consideration. For instance, where are the wireless clients located? Right? You want to make sure that you place the wireless access point, and which, by the way, if you're not clear on what a wireless access point is, it's just what it sounds like. It's a device that will actually physically connect into your network, right? So you'll have cables going to it, and then it is able to communicate wirelessly with everything else. So the everything else, all the clients, where are they located? Right? If you have an office, and let's say everyone who's going to be connecting wirelessly is over on one side of the office, and you place the access point all the way on the other side of the office, maybe that's not a good idea. How far can the wireless access point send and receive its signals? Different wireless access points have different specifications. So how far of a signal can it send and receive? And by the way, it's not just an issue of how far, can we make it to the clients that we're trying to connect with? But in some cases, you want to make sure that it's not going too far and sending and receiving signals out to an area where somebody else might actually be trying to break into your network. So you may need to use a directional antenna. That's a question that, if you have an access point that has the ability to use a directional antenna, maybe you put it at one edge of where all the clients are and you send the signal all out in one direction. Or again, do you need to prevent certain areas from receiving the signal? Do we want to make sure that the signal does not leave the walls of our office? Do we want it to expand all the way out to where someone could be out in the parking lot, see the signal, and then try to break into our network? These are all things that we need to take into consideration when placing our wireless access points. Now, there's a number of different wireless networking standards that are out there, and there's 4 in particular that we're going to talk about here. The first 2 are considered to be older, out of date, not heavily used anymore. We have 802.11a, and by the way, 802.11, there is an organization out there called the IEEE. I won't bother you with what the letters stand for, but it's a bunch of geeks. You've heard me say that before. And they set up various standards. Well, there is a standard called 802.11 And within that standard, they've broken it down into various wireless standards. The first one is A, right? The 802.11a standard. It is a wireless technology that operates on the 5 gigahertz frequency. Frequency is important, by the way, for interference. But basically, when working with the airways, you have to go ahead and communicate on certain frequencies. And if there are other devices on that same frequency, we could get interference. And the 5 gigahertz frequency happens to be a fairly popular frequency that is used by many different devices. It can handle data rates up to 54 megabits per second. Please keep in mind that the data rate is not necessarily the actual end result throughput. Okay, so just because it can handle the actual data rates up to 54 megabits per second, the actual throughput that you see could be less than that. And it didn't actually have very long ranges. Okay, it really could only go up to 100 feet at the most, and it was very easily obstructed. And I'm going to add to that again, very easily interfered with by other 5 gigahertz devices. You know, at the time there were a lot of 5 gigahertz wireless telephones, baby monitors, all kinds of stuff. We then had the 802.11b standard, which used the 2.4 gigahertz frequency. We didn't have as much interference, but we did still have interference. You'll notice the data rate was much slower, maxed out at about 11 megabits per second. And again, the throughput that you would see as a user might be more like 5 or 6. You did have a better range. You still had 100 feet if you were indoors, going through walls, things like that. I know I used 802.11b in my house, and I have a 3-story house. Well, it's really a 2-story house, but I also have a basement. And I put my wireless access point in the ceiling of the basement. I have a drop ceiling in my basement. I had it up in the ceiling of my basement in a central area of my house. And I was able to pretty much, for the most part, other than maybe if I was in the furthest corner of the top level of my house, for the most part I got a signal. Okay, so you could get 100 feet indoors, and you could get up to 300 feet outdoors, meaning if you had no obstructions in the way. So it was slow, less interference, and you could get a longer distance than A. But we don't really use either A or B that much anymore. What we do see in today's world is 802.11g, and even that one's quickly becoming outdated. But 802.11g was an enhancement to the B network. You still use the 2.4 gigahertz frequency, but we now went back up to getting data rates of 54 megabits like we got with the A network, while we still had the range of 100 to 300 feet depending on our obstacles. 802.11g was very popular for quite some time. What we have most prominent in today's wireless networking is 802.11n, which actually has the ability to use both 2.4 gigahertz and 5 gigahertz frequencies. It can get data rates, I have listed here, of 100 megabits per second. Actually, they've now enhanced it to where we can even do better than that. It uses something called MIMO, M-I-M-O, multiple in, multiple out, where we basically are transmitting and receiving more than one signal at a time using multiple frequencies. Okay, so that's part of how we were able to enhance our data speeds. And we have long ranges up to 1,000 feet or more. Again, 802.11n opened up a whole new ballgame in the world of wireless. And I don't know of any specification that's going to knock N out of the industry, at least not in the immediate future, because they keep making enhancements to the 802.11n networking standard to be able to be faster and travel longer distances. Now, I mentioned at the beginning the benefits of wireless, and at the end of those benefits, I said it's equally as secure as a wired network. But I put it with a question mark, like, is it? Well, there's a number of things that you can do to help make it as secure. Okay, now the first two I have listed here really don't help. Okay, I mean, they kind of keep the honest people honest, but that's about it. All right, the first two can be so easily overcome that I could probably challenge my 9-year-old and he could do it. All right, so the first thing is something called Disable SSID Broadcast. Now, the SSID is the name, basically, of your wireless network. Right? When you have a wireless access point, it basically is going to say, all right, I'm the blah, blah, blah network. Okay, so like at one point, my home network, it actually said Ed's Home. That was the name of my network. And so it broadcasts out and says, hey, I'm here. I'm a wireless network. I'm called Ed's Home. And if you want to connect, here I am. Well, you could disable that broadcast. Now, if you disable the broadcast, that makes it a little bit more of a challenge to connect, even for the users who are supposed to, right? Like if I'm in my own house with my own laptop, I can't just click to say, show me a wireless network that I want to connect to. I'd have to manually type it in and say, no, I want to connect to a network called Ed's Home, and here's how it's configured. But you can do it. You could also do something called MAC filtering, and MAC has to do with the media access control, or the MAC address of an actual network card. All network cards have these unique addresses. You can actually put on a filter on your wireless access point that says, I will only talk to these specific wireless clients. Again, not very secure because it's not that hard to do what's called MAC spoofing. Okay, it doesn't take a lot of intelligence to figure out how to take a wireless network card and have it pretend to have a MAC address that's on the approved list. All right, so this is not very good security, but it is basic stuff that you can do. The next step in securing a wireless network would be to use something called WEP. W-E-P. And it's funny because if you ask people what WEP stands for, the average person will say the Wireless Encryption Protocol. Seems to make sense, right? It's what it was. It was the very first form of encryption of the data, right, to keep it secure. So it makes sense. Wireless Encryption Protocol. No, that's not what WEP stands for. It actually stands for Wired Equivalency Privacy. The idea behind WEP when it was created is that you could encrypt the data that was being transmitted over the wireless network, which would then make it as secure of a connection as a wired network. I kind of laughed there because it was later found to be very easily cracked. I could go on the internet right now and I could just do a quick little search for WEP cracking tools. There are plenty of free ones out there, and they'll go out there and easily crack that encrypted transmission. So to say it's wired equivalent, yeah, not so much. But then we moved over into Wi-Fi Protected Access, or WPA, which then became an actual standard as WPA2. It was designed as an improvement over WEP, and it was. It uses something called TKIP, which is a hashing algorithm used to scramble the encryption keys, and can also use the Extensible Authentication Protocol, or EAP, which is based off public key encryption technology and has much more secure way, or really is, I should say, a much more secure way to verify authorized network users. WPA2, short version, it was actually the ultimate standard, as opposed to WPA was more of a thought than a standard. It was an idea and it was implemented, but not a standard. WPA2 became a standard. It was designed as yet another improvement over WPA. It has the ability to utilize AES CCMP instead of TKIP, which, again, I'm not going to go into deep details here. There are wireless courses that really go into detail and spend hours talking about the actual encryption technologies and hashing algorithms and all that fun stuff. But the bottom line is it is a stronger and more scalable form of encryption. Now, I will tell you that WPA and WPA2 also come in two different flavors. There's personal and enterprise. Again, I'm not going to go into deep detail, but personal is the one you typically see, especially in like a home environment. Enterprise requires the implementation of 802.1x, which I actually have listed here on the next screen here. 802.1x, you'll see, requires the use of certificates and radius, neither of which are just automatically, quickly, and easily set up. There actually is the need for some enterprise configuration and planning and thought, and it's not something you're going to learn in 30 seconds and then boom, you go do it. But the short version is certificates are used to provide a higher level of authentication than other standard basic forms. And a radius server is used to centralize connection requests and also maintain an account of who's connecting, when did they connect, for how long, so on and so forth. So again, the intent here is not for you to have a full understanding of how to implement 802.1x. Just want you to understand that if you were to go to this level, then guess what? If we go back to the beginning where I said equally secure, it can be equally secure to a wired network. because you will have strong encryption in place along with additional security mechanisms to make sure that your data is protected just as much as it would on a wired network. And that brings us to the end of the wireless networking lesson. So I thank you for watching, and I will see you in the next lesson.